Hello everyone. So this is the last question of 2023 stats paper which you have tomorrow. So we are left with question 7 only. And in the previous videos I have solved for part A separately, then question 5, then question 6. So these questions are very important. And 5, 6 and 7 because collectively they have a weightage of 50 marks. You are supposed to attempt any 2 out of 5, 6 and 7. Okay, so starting with the question. An engineer at a construction firm has a subcontract for the electrical work in the construction of a new building. From past experience with this electrical subcontractor, the engineer knows that each light switch that is installed will be faulty with probability P equals to 0.02. So we have P equals to 0.002. So this is the chance that the light switch would be faulty independently of the other switches installed. The building will have n equals to 1500 light switches in it. So it is given to us n is 1500. So if P is this, Q becomes 0.998. Let X be the number of faulty light switches in the building. Okay, X denotes faulty light switches. Find approximate probability. So we are supposed to find probability X lies between 4 and 8 when 1500 switches are there. Which distribution do you use and why? So since we know that n is 1500, which is very large, that is n is greater than 50 and P is small. The value of P is 0.002. So n into P, 1500 into 0.002. So this is coming out to be 3, which is less than 5. So with n greater than 50 and n and P very small, less than 5, so the distribution of X can be approximated to Poisson distribution with lambda equals to n into P. So n into P was coming out to be 3, which is equals to 3. Now for the Poisson distribution, we are supposed to find this. So this would be f of 8, this is cumulative, minus f of 4. So this would give you the probability. Okay, so we are supposed to discuss the Poisson distribution. To find from the Poisson distribution when the mean was 3. Cumulative Poisson distribution, mu is till 1, so no need to say this. When mu is 3, we need to find f of 8 minus f of 4. So f of 8 is coming out to be 0.996. This is f of 8. F of 4 would be 0.815. Given the mu level, this is how you interpret the table. Minus 0.815. So, okay. So if you'll solve this, 0.815, 181. So this would be the probability. If it was 4 including or exclusive, I'm not sure. Okay, so 4 including. So had it been the case, if it was probability 4 strictly less than X greater than equal to 4, then this would be the right answer. But since 4 is also including, we need to find f of 8 minus f of 3 because this was including. So we already know what f of 8 is. F of 8 is this. F of 8 is this. F of 3. F of 3 is 0.647. So it would be probability 4x8 is f of 8 minus f of 3. So this would include 1, 2 and 3. So f of 3 is coming out to be 0.647. So this is equals to 0.996 minus 0.647. So the value is coming out to be 0.996 minus 0.647, which is coming out to be 0.349. So this would be the probability that x would lie in this range. Okay, now moving to the B part. Okay, so we have done the first part. Now we'll move on to the next part. Okay, the yield strength for a particular type of steel is normally distributed with mean x follows normal with mean 43 and standard deviation 4.5. This is given to us. What is the 25? What is the 25th? What is the 25th percentile of the distribution of this steel strength? So we need to find the value of z such that what is this value we need to find. So with the help of the table, so we have x minus 43 by 4.5 should be, this should be equals to the z 0.25 value. This we'll find with the help of the table. I'll tell you how we are supposed to find with the help of the table. So we are supposed to find 0.25 for the standard normal distribution. Okay, now you need to look at these things to find the to find the percentile. So I have already marked it because it would have taken time to find it. So this is 0.2514 and this is 0.2483. So effectively this is coming for when z is close to minus 0.6, then the other decimal would lie in between this. So we can, which one is closer? So this is 14, this is 17. So this one is more closer. Or if you want to round it off, you can take it as this as well. So z 0.25 would be minus 0.67 or 68. Both would work. Or you can take the average of it, which would be minus 0.675. So corresponding to this row and these two columns, average of these two columns, because they are very close to 0.25. So we'll take these value or an average. Suppose we take minus 0.6 minus 0.6 from here and the average of them. So it would be minus 0.675. Now solving the question. So this is coming out to be minus 0.675. Now you can solve this. So 4.5 into minus 0.675 equals to plus 43. So the value is coming out to be 39.96. So the 25th percentile value is when x equals to 39.96. Okay, now moving to the next part. What strength value separates the strongest 10% from the others? So basically, given the normal distribution, we need to find this value z 0.9 so that the remaining value is 0.1. Okay, so looking back at the table again for the standard normal distribution. Okay, we need to find for 0.9. This is still 0.4. Okay, we'll move forward. Then 0.9 is here. Okay, this is the closest value. This is just by 0.003 lower. So this is more closer as compared to this. So we'll take this value. This corresponds to 1.2 and the decimal would be 1.28. So z 0.9 is coming out to be 1.28. Okay, so what we have is z 0.9 equals to 1.28, which means 1.28 equals to x minus 43 upon 4.5. So 4.5 into 1.28, this is coming out to be 5.76 plus 43 equals to x. So x is coming out to be 48.76. So when x is 48.76, this would mean 90% of the value. So at this is 48.76, 90% of the values lie below this. Okay. Now moving to the next part. Now the next part states what is the value of C such that the interval 43 minus 1, 43 minus C, 43 plus C includes 99% of all strength values. So basically this is the mean 43, and you need to check what values, okay, what values would C take such that 99% values lie between this interval. So basically 99%, that would mean 49.5% lies here, 49.5% lies here. So we need to find this remaining value, this value and this value, since it is a normal distribution which is symmetric in nature. So if we find value of any one of it, we'll be able to find the value of the other one. So if this is 49.0.5, so this would be 0.5 percentage, which is 0.005. This would be 0.005 as well, the area. So Z 0.005. Okay, now coming back to the table again. When Z is 0, we need to find the value of Z when the area is 0.005. This is 0.005. Okay, just make sure you don't make this mistake. So 0.005. Okay, these are the closer values. So we can take, suppose, and this corresponds to minus 2.5, then 8. Okay, minus 2.58. So what we have is, this is coming out to be minus 2.58. X equals to mu minus C. Right? Now, with the help of this, we can write x minus mu equals to minus C, and x minus mu by sigma equals to minus C by sigma. So minus 2.58 is equals to minus C by sigma. And since sigma was, minus minus would cancel out, sigma was 4.5, so C becomes 4.5 into 2.58. So this would be 4.5 into 2.58, 11.61. So C is coming out to be 11.61. So the range would be 43 plus minus 11.61. 43 minus 11.61, 31.39. So 31.39 till 54.61. This interval consists 99% of the observations. Okay, now moving to the next part. Okay, now moving to the next part, what we have is, what is the probability that at most 3 of 15 independently selected steels have strength less than 43. So now N is 15 and strength less than 43. So it would be, since it is symmetric about 43, so 50% of the observation would lie here, 50% of the observation would be above 43. So P is half, because 50% of the observation would lie below 43. So probability X less than 43. So x minus 43 by sigma, and 43 minus 43 by sigma. Sigma was 4.5. So this becomes z. So this is probability z less than 0. So we'll see what the probability of z less than 0 is. This is the standard normal distribution only. When z is 0, this is 0.5. Okay, so the probability so what we have is the probability this is equals to half, and the probability that, okay, so we have done this. What about it? At most 3 of the half strength less than 43. So we need to find probability x less than equals to 3. So this is the cumulative with p half and x3. x3. So this is n, this is p, this is x. So we'll find this. P is half, n is 15, x is 3. Binomial Poisson. So we are talking about the standard normal distribution. I'll just check. So z value was, I'll just check again what we were supposed to find. F of npx when probability x less than 3. Okay, so we were supposed to find for probability, I'll just check it once. Okay, so we were supposed to find this np, so the mean would be 7.5, then 3. Okay, you can just check it because not sure z is close to 0. So we are supposed to find for x less than equals to 3. So x minus 45 or 43. X minus 43 by 4.5 should be less than equals to 3. We'll get the value for x. Okay, so you can just try this on your own. I'm not sure where exactly the value would lie in this case. So if you have the standard normal distribution with you, you can check with the help of the table. You can just check it once. And so the main thing is that this is the cumulative distribution and you need to find for x equals to 3. So I solved it previously, but I'm not sure, but I got this value. I'll just check it from the table. Okay, so okay, let's skip. I'll do this at the end, or I'll post in the comments about how you're supposed to do this. Okay, now moving on to the last question. Let x and y be independent standard normal distribution. So it is given to us that x follows normal 0 to 1, y follows normal 0 to 1. Consider the following linear transformation of x and y. U equals to ax plus b, v equals to cy plus d. And they are independent. So if they are independent, okay, first we are supposed to find correlation between u and v. So first thing, what is correlation coefficient? It shows a linear relationship between two independent variables, and this is linear in nature, and you should know the range of this. The range of this is -1 to 1. So if you are getting a value higher than this, your answer not in this range, so your answer would be wrong. Okay, now since x and y are independent, we know there is no relationship between them, so covariance xy equals to 0. Now u is ax plus b, V is Cy plus D. Okay. Now you are supposed to find the correlation coefficient between U and V. Firstly, expected xy equals to, so covariance xy equals to expected xy minus expected x into expected y. And since this was 0, we have expected xy equals to expected x into expected y. And since it follows the standard normal distribution, the standard deviation is 1. So the variance would be 1 as well for both these distribution. Now we have u equals to ax plus b. So u bar would become a into x bar plus b. V equals to cy plus d. V bar becomes cy bar plus d. U minus u bar becomes a x plus b minus a x bar minus b. So b cancels out. So we have a times x minus x bar. V minus v bar becomes, similarly v minus v bar would become c times y minus y bar. Now u minus u bar square would become a square times x minus x bar whole square, and v minus v bar square would becomes c square times y minus y bar whole square. Now, okay, so far we have got this. Now solving it further, now we are supposed to find covariance uv. So covariance uv would be 1 by n summation uy minus u bar v minus v bar. So you must be aware of this formula. So this is 1 by n. Ui minus u bar was this term. So this would become 1 by n summation 1 by n bracket summation a times x minus x bar into c times y minus y bar. So we can take a and c common since they are constants only. So this would become ac upon n summation x minus x bar y minus y bar. So this is ac upon, look at this thing, the one in the red. This is nothing but 1 upon n summation xi minus x bar y minus y bar. So this is covariance xy. So this would become AC times covariance xy. And since covariance xy was 0 because they were independent, so covariance uy would also become 0. Okay. Now we were supposed to find correlation xy. So it is covariance, no, so we were supposed to find correlation uy. Okay, so for correlation xy, the formula is sigma x by sigma y. Similarly, for correlation uy, uw, uv, it would become covariance uv upon sigma u sigma v. Now we already know this is 0, so we don't need to find this as well, although it is easy to find this, but no need to find, so this would be 0 itself. Okay, now moving on to the next part. Justify your answer using, we have done this. Okay, so I'll clear up some space before solving the last part. Consider random variable w equals to 0.6x plus 0.8y. So this is a random variable that has been created. Determine correlation xw and correlation yw. Compare both with correlation xy. So correlation xy, we already know it as 0. Now we are supposed to find correlation xw and correlation yw. So we already know that correlation xy is 0 and sigma x square equals to 1, sigma y square equals to 1. Well, I'll take just a minute's break. Okay. Now this thing is given to us. So covariance xw would be expected xw minus expected x into expected w, and expected xw, this would be expected x into w. So this would be 0.6x, this would be 0.6x plus 0.8 y. So this would be expected of 0.6 x square plus 0.8 xy. Now taking expectations inside, we'll have 0.6 expected x square plus 0.8 expected xy. So this is expected xw. This is what we are getting. Now the second term, this is the second term. So expected x into expected w, this would be expected x into expected of 0.6x plus 0.8 y. So we have expected x into 0.6 expected x plus 0.8 into expected y. So this becomes 0.6 expected x whole square plus 0.8 expected x expected y. So covariance xw would become this term. This was expected of x into 0.6 x plus this. So this would become 0.6 expected x square plus this. Okay, so this would, okay, so we are getting this value. And since expected xy equals to expected x into expected y, because covariance xy was 0, so this thing would become this term 0.6 expected x square plus 0.8 expected xy minus 0.6 expected x whole square minus 0.8 expected x expected y. Since these two are equal, they will cancel out and we are left with 0.6 expected x square minus expected x whole square. So this would be 0.6 into sigma x square. So this is the variance of x only. If you will remember this formula, this is the formula of variance x. So we are left with 0.6. So we have found covariance xw equals to 0.6. And let us see the transformation that was being made for w. Now if you will see it, w was 0.6x times 0.8y. And so the covariance of x and w is coming out to be 0.6 sigma x square. Okay. Now talking about the correlation. Okay, I'll just now we have got this. We'll see what would happen to the correlation. This was W equals to 0.6. Now correlation is covariance xw upon sigma x sigma w. This was 0.6 sigma x square upon sigma x sigma w. So this cancels out. So this is, don't know why this is facing a lot of problem today. Okay, I won't be doing this again. So we were discussing about the correlation and we got covariance xw was coming out to be 0.6 sigma x square. So we had this correlation xw would be covariance xw upon sigma x sigma w. So this would become 0.6 sigma x square upon sigma x into sigma w. So this cancels out. So we are left with 0.6 sigma x upon sigma w. Now w is this. So sigma w square would become 0.6 square sigma x square plus 0.8 square sigma y square. Since they both follow standard normal distribution, this is 1, this is 1. So we have 0.36 into 1 plus 0.64 into 1. So this is coming out to be 1. So sigma w would also be 1. And sigma x is also already 1. So the value is coming out to be 0.6. And look at this. Covariance xw is 0.6. And this was the coefficient associated with x as well. So similarly, what we'll see is the covariance, the correlation yw would be equals to this 0.8. I'm not doing it. You can do it by yourself. Okay. So we are done with the past year and I hope your paper goes well tomorrow. And so I hope you will be getting some options as well. So try to have a good at least 5 or 6 hours. 5 because there are a lot of students I have heard they don't even sleep. So at least ideally it should be 6.5 or 7 hours of sleep. But okay, since this is an exam time, so at least try to have 6 hours of sleep. 7 would be the ideal one, but at least try to have 6 hours of sleep. So that is required because the questions would be a bit practical in nature. So it would require, the paper is technical in nature and you are required to use your brain during that time. You're not supposed to just mug up things and write it down there. So try to revise the formulas as well for the mean variance of different distributions. Okay, all the best.